Hello, my name is Phil Sewell. I'm the Strategic Security Architect for Voltage Data Privacy and Protection here at Micro Focus. I'm joined by Neville De Silva, a Voltage Solution Architect. We're going to be discussing today how to enable secure data analytics for the Snowflake Data Cloud with Voltage SecureData. I'm going to introduce you to the innovations within the Voltage SecureData platform that makes this possible and explain the reference architecture for the combined Voltage and Snowflake solution. Neville will then demonstrate the capabilities live using Voltage SecureData with the Snowflake Data Cloud. This is a high-level reference architecture diagram showing the entire story, moving left to right in terms of how the data is protected, how it moves into the Snowflake Data Cloud, and then how it's accessed, whether it's accessed in its protected form or whether we're accessing decrypting or detokenizing the real data. So we're going to break this down, but the general principle here is depending on the specifics of the security requirements here, we may want to protect this data on-premise before we move it to the cloud. So that can happen in many different ways through traditional ETL tools. This data could actually be protected already using Voltage SecureData at its closer to its source origins. Our own structured data manager can help with the discovery and classification of sensitive data and then trigger the protection, the encryption, tokenization of the data with secure data. But many of these options would be preferred to be used to protect data before moving that data to the cloud. In the middle, of course, this is where the data now is protected at rest, in use, and as it potentially moves around within the cloud components. And then the right-hand side, again, is talking about the various ways that users interact with this data. We'll explain the use of the Cloud API in just a second. Okay. So again, left-hand side, the ingestion of this data, we are looking at protecting the data at the field level using really a combination of field level format preserving technologies. We have a variety of APIs and tools that can do this and integrate with tools like Informatica, for instance. All of this, of course, is using the Voltage SecureData stateless key management system. And the true benefit here is if we are talking with customers that already protect data with Voltage SecureData, that data can simply move in to the Snowflake Data Cloud in without any further work going on. Now, once the data is in the Snowflake Data Cloud, we don't need actually any Voltage software to continue to provide protection. That job has already been done prior to moving the data to Snowflake. So for a large amount of users that will be doing analytics using protected data, and we'll explain how that is done in the demonstration, there is no actual use of the Voltage software. So the benefits of format preservation, keeping the data in the same length, the benefits of being able to do partial protection of data can extend the life of this data for analytic purposes without decrypting or detokenizing the data. And of course, the transformation of this data still guarantees the data's uniqueness and the referential integrity of the data as well. Now, when we do need to decrypt or detokenize this data for people that are allowed to see it for true business reasons, there is a number of things we can do. So today, what we are demonstrating and talking to customers about is basically leveraging the native capabilities of the Snowflake Data Cloud, specifically how users are given permission into certain roles, the masking policies for certain columns and tables, and the capability to invoke an external function from Snowflake. So when a user has a role, and that role is allowed to invoke a function on a specific column, that function actually makes a call to a cloud API gateway. AWS call this the AWS API gateway. Microsoft Azure call it API management. So we have done testing on both of these cloud API capabilities, and that in turn invokes a Voltage SecureData Cloud function. In the AWS world, that is a Lambda function. In Microsoft Azure, that is an Azure function. So those functions are going to be working next to that cloud API environment. And all it needs from the Voltage SecureData key servers at the bottom of this diagram is the actual encryption key, and it's going to ask for it, and that key will be derived, and it's going to be exactly the same key, the symmetric key that was used to encrypt the data at the start of this process on the left hand side. So really the access to the data is done without the user knowing the functions that are being used to decrypt or detokenize this data more transparently. And all this is done really by their part, their having a role that allows them to see certain data rather than other data. The use of the cloud provider's API, whether that be AWS API Gateway or Azure API Management, as we're showing here in the diagram, is just one way that this combination of technologies could work today. So we are investigating the development of a user-defined function for the Snowflake Data Cloud. In that situation, that function would be installed in the Snowflake environment, and there's two possibilities to how that function would work. It would work using our simple API, where the simple API would request a key from the Voltage SecureData key servers directly, and obviously cache that key for optimal performance and perform decryption operations within the Snowflake Data Cloud itself. The REST API would be an alternate approach to that scenario. In either case, that would then bypass the use of a cloud API. So it is something that our organizations are investigating today. So in the example Neville's going to show, we have a number of users. Neville will be a user with an HR role. We have Rich as a demo user for finance. A customer service rep is Monica, and we have the sysadmin role as well. So you can see here, these are not all the columns, but this is a good number of them. And you can see that the check marks are indicating that these specific columns of these tables should be visible to those people with those specific roles. So as you can see, that most of the users except the sysadmin should be able to see the person's name, meaning the function to actually decrypt the name is part of their role. City and state, as well as the credit score on the bottom, are all actually clear text values. There's no real need to encrypt, tokenize these values, as they're not of any significant value on their own. So they are actually left in the clear. Email address, date of birth, we can see how those are protected and accessible to certain roles. Date of birth is something a little bit more sensitive, and only the HR role has access to that. The credit card number, for instance, is only available for someone in the finance role, and not HR or customer service reps. The other thing to keep in mind here is that we actually have two tables. We have the main table that's holding the person data, and we have a credit score, and how those tables relate is by a join on the social security number. So we're going to show basically how data can be analyzed across two tables in a join without the requirement to actually decrypt that primary key and foreign key column. So in the demonstration that Neville will take you through, we'll have a look at a sysadmin account to see what the data looks like in the base table. We can see that certain columns are clearly protected. Actually, it's using a mode called obviously protected mode, like how we're protecting the social security number. But the sysadmin, although they do have, they've been used to create a lot of the underlying roles and functions and masking policies, they actually don't have access to see the real data themselves. So then we'll step through a number of users, the finance user, and how they are not able to see the social security number, but when they do a join between the two tables, they can see decrypted names and the credit scores, but they can actually do that without decrypting the social security number. Now the HR user can see things like the social security number. They have access to their role gives them access to decrypt the social security number, but not the credit card number. And when they run the same join, we'll get exactly the same results, but they actually will see decrypted social security numbers. So if we look a little bit further, we go on to step 3 here. The HR user queries the main table, and really all this is driven by the roles that these people have. So because they don't have a finance role, they cannot see the tokenized credit card. And actually, to keep things to simplify things for the end user, instead of showing a tokenized credit card number, we're actually showing a null value. So that is, Neville will show you how that is done in the definition of the function. The dates of birth, again, are extra sensitive in some businesses. So the finance user tries to see the date of birth, and of course they are not able to see that. And again, we are not complicating things here by showing an encrypted date of birth that that will look like a real date. Instead, we are simply returning a null value, so they can clearly see they cannot see dates of birth. Whereas the HR user can actually see the decrypted dates of birth. The customer service rep in step 4 has a mix here, right? So this person does need social security numbers, but not dates of birth. So it shows the granularity here of how these roles are used in combination with the users and the masking policies. Then we'll go back to the sysadmin user and see how the roles, functions, and masking policies have been defined. Over to you, Neville. Thanks, everybody.
Thank you, Phil. Let's look at some of the real-life data here. And like you described, what we have here are 2 tables, which we call as voltage table, which has the sample data as shown. So let's quickly look at it. As you can see, we have name, addresses, email, credit card, date, and social security number. These values are stored in the database in a protected format. We also have a table for joins, which is called credit_score. And let's look at the sample data from that table. We have a social security number and we have the score. For this demonstration, we are going to rely on the 4 users, like Phil mentioned, and they are going to be assigned to 4 roles. There is going to be a sysadmin role, which will be used for doing the sysadmin activity. Then we have a human resources role, a finance role, and a customer service role. For each of these roles, we create 3 for the users. We have Neville, Rich, and Monica. So let's go to the step 1 of the demonstration, where we look at the different behavior based on users' membership in a certain role. So we are looking at a finance user logged in as a finance role. So we have Rich in the finance. If Rich tries to access the social security number, let's see what he sees. As you can see, Rich is able to select social security number, but this is the obviously protected social security number. This is not a clear text social security number. And this is because Rich does not have access to the social security number. But will he be able to run a join where the join happens on social security numbers between two encrypted tables where SSN is protected in both of those tables. So let's run this query. We're trying to get the name, social security number, and the credit score of the person from the table. For that, we will have to join the person table or the voltage table and the credit score table. So we have the name, which is decrypted. We have the encrypted social security number. Remember, the finance users do not have it. And then we have the credit score. How would this be different if somebody is in the HR role? So we have an example of a user Neville who is in the HR role. And let's go ahead and run the similar query as what we did with the finance user. So if you look at the SSN, now you would be able to see the entire 9-digit SSN number instead of the protected alphanumeric as you saw here. So this shows that the HR user has full access to the social security number and the decryption of it. How would the join be different for this user versus somebody in the finance role? So the same query, the only difference is we also saw Fabian in this being returned, but instead of the protected social security number, which you saw in the case of HR, in the finance, in the HR case, you're going to see the decrypted social security number. Notice the users logging on are differentiated based only on their role membership. We have not done any difference in the query which was run. Now, what happens when an HR role tries to look at the credit card information, which HR role doesn't have access to? They can still run the queries, but instead of seeing the credit card information, they are going to see a null, which shows them they do not have access to the data. Now, if somebody in the finance domain, for example, Rich, runs the same query, he should be able to see the credit card data because his user is allowed access to that data. If Rich tries to go to some data like date of birth, which is really reserved only for the HR, then let's see what he gets. He's able to select name, city, but not the date because he do not have access to that. So we should be able to go back to the HR and still be able to see the date in the clear, as you can see it here. We also have the third user, which is a customer service rep, where they would need to see things like social security number. So let's run this for the employees or for the customers, and they can see the entire social security number as you can see here. This user does not need to see the date of birth. So if we try to run this select as Monica, I am not able to see the date of birth for the employees or customers. Now, the user which created all of this, or the ETL user, is in this case sysadmin user, and sysadmin user initially created this roles as well as assigned the users to these roles. Let's see what sysadmin can see. So if I go to the select star from table and run, I should be able to return data where I have access, but I do not have access even though I created the other roles as sysadmin. I do not have access to see the names, the emails, or SSN and other data. Let's look at how these roles were created. We created individual roles for the three categories like HR, finance, and customer rep. Then we assigned users to that role, and then we provided grants to those roles so that they will be able to do database operations. The real magic which happens behind the scenes is the power of the functions, which actually helps us to decrypt the data. Like Phil suggested earlier, data by default is always in its protected state, as is the state you can see here. The name is really incomprehensible to our naked eye. I mean, it looks something like a gobbledygook, but this is Fabian's data we are looking at here. And the email address is protected as well. So the functions, you have a number of things. What am I trying to do? I'm trying to unprotect the name What do I need to unprotect the name? Like Phil mentioned, it is going to refer to in what is termed and voltage terms as an identity, which is used for protection of the name, and a format. So we have a format defined here as well as identity. And to make this function more efficient, we can even batch some rows or a number of rows to perform efficient operations. So as you can see, I have specified the max batch size here as 1,000,000. And then you could do the functions, similar functions for unprotection of email, dates, and so on. As a final step, what you will do is you will create the masking policies using these functions. And these masking policies correspond to the slide which you saw earlier. We are going to apply masking policies for the name, email, date, credit card number, and the SSN number. So let me go and show you the masking policies. So here we start creating the masking policy. This is the masking policy for the name. As you can see, if the role belongs to HR, finance, and customer rep, so in our case, all the 3 users which we looked at, they have ability to decrypt the name. You could very well change it as your needs change. Similarly, email is allowed for everybody for decryption. Once you go to the birth date, only the HR users are allowed to decrypt the birth date. And we have an option here. Either you could return a value, as we are doing the case here, where you would be able to see an encrypted email instead of a null, or you could say, I want to show you a null, not an encrypted email. The change is a really small change in what comes out of the function if this primary case is not true. So we created the masking policies for credit card numbers, social security numbers. So that really concludes the demonstration on my Snowflake. If you have any questions, feel free to reach out. Thank you.